This is the Continuum Lab. I'm Jeppe, musician, maker and your host on this visit. Today something a little bit different is going on in the Continuum Lab as I will be assembling and trying to run a machine of my own design and making, which is not a musical instrument, and that is highly unusual here in the Continuum Lab, but it does have to do with the open horn MIDI system, specifically with the keys that I made a couple of weeks back, so I'll show you how those turned out. But first, a short disclaimer.
The continuum has no end and no beginning. It represents the sum total of all knowledge, stretching from the unnoticeably small and to the incomprehensibly vast. So the Continuum Lab is not really a physical space at all. I think of it as a state of mind, like a mental leap of faith from the comfortable platform of the known and into the infinite ignorance, where learning is the only method of propulsion. Welcome to the Continuum Lab.
The final thing that I did to the keys that I made a few videos back was cover them in a layer of epoxy resin. So I want to show you how that epoxy layer turned out and what I like about these keys and what I don't like, and why I'm going to make a new batch of them using a slightly different technique and also using the machine that I just mentioned earlier. So let's have a look at that. As you can probably see, I already did a lot of work on my little machine here, and I really just need to hook up the power supply, which is this thing here underneath, and I think I should be up and running. So I'll show you that in a second. But first of all, let's have a look at those keys. So here are the two sets of keys that I printed out and finished in their original frames. And then here is a couple of keys that I took out of the frames and inserted into this piece of bamboo here. So yeah, I wish I had a macro lens to show you this closer up, but I'm sure you can see that there are some scratches on the copper electrodes here within the key, and that's because I sanded the copper tape down so that the epoxy would have a more stable bond to it. But I think that's actually not really necessary. I'm going to try it with smooth copper tape underneath, and then I'm going to try a separate one with some very, very fine sandpaper so that the scratches will be much more discreet. Another flaw here is that some of these keys, specifically like this one here, managed to drain out the epoxy resin, I guess through some of the small holes in the epoxy putty that is underneath the platform. And so instead of having this beautifully rounded surface that we get here from liquid surface tension in the epoxy, we get this sort of ugly thing, which I don't like. So so that's easily fixable. I'll just have to be more careful in applying the epoxy putty. The final thing, and the thing that's actually the reason why I'm making the machine that I'm currently working on, is that the aforementioned nicely rounded shapes here are not perfectly regular. So after I left my epoxy to dry, there was a slight tilt in the position of this frame here, and so all the keys would tilt a little bit, and so the sort of flat bubble-like surface here is actually a little bit thicker on one side than on the other. And so that brings me to the machine. Let me give you the lightning quick rundown of what I'm trying to do here. What I want to make is a rotary frame for curing epoxy, so that I can minimize the problem that I had on these keys with the epoxy layer drooping off to one side because of gravity. And I will do that by suspending each key individually in a rotating frame, where the gravity will then shift the epoxy resin and hopefully make a perfectly smooth layer, which is what I want. The machinery here is actually a recycled project which had a stepper motor hooked up to a stepper motor controller, an Arduino Micro, and a potentiometer to vary the speed. So that's actually exactly what I need for this whole setup. I had disassembled this when I moved last year, and so now I found all of the bits and pieces, and I'm trying to put them back together. So as far as the rotating frame where I will fix the keys to, I just 3D printed some bits and pieces for that. So that looks like this and like this. My idea is that these two small wheels here are glued together, and so the little channel here holds a rubber band, which is then driven by this other little wheel here, which has a much smaller channel here where the rubber band will run through, and then this is stuck on the stepper motor. This piece here is the support that will hold the rotating frame itself. So inside here goes an M8 threaded rod. On that same threaded rod goes this wheel here, the driven wheel. That will make the threaded rod rotate. There are two bearings inside here for that purpose. And then this is attached to the outer edge of that whole thing and will rotate slowly around with the keys attached out here. So I do need to make some kind of surface underneath it which will pick up any drips that might occur. But I think that with the rotating frame, dripping should be minimized, perhaps eliminated altogether. So we shall see how wrong or how right I might be about that. Anyway, let's get building. There, that's glued. Am I losing light here? Yeah. So that's the rotating frame part of the setup. Oh, damn it. I just realized that I have to put these screws through here before I fix the driven wheel on there. There, the screws are in. And now that I think about it, of course I need to fix this to the wall before I reattach the driven wheel and the frame itself. So the way the frame works is super simple. You just take an individually printed key, such as this one, and you just grab it about half a centimeter down the cable, and then you just run it down to the bottom where the cable gets narrower, and now it's locked in place. So then you have some cable sticking out the end here, and you can lock that into place next to the slot where the key is, and so this is going to be rotating and hopefully not getting caught on anything. Okay, let's put that aside for a second. Let's see if I can get this stepper motor up and running. Here's the 12-volt supply lines which are going to run the motor. And I want to connect those to the 12-volt supply lines on the power supply. So, let's go. That's 12-volt line. Then for the microcontroller and the rest of it we have a 5-volt line, and that's this one here. Moment of truth, I guess. Time to plug it in and see if everything explodes. So I remember putting a switch on here at one point. An on-off switch for the whole circuit for the power supply, and it's in the off position right now, so I'm really happy with that. Just plug this in and see what happens. Nothing. Nice. That's what I was hoping for. Turn this on. Yes! Let me just get something real quick so I can show you that. Check it out. Speed up. Slow down to a full stop. And then start reversing. At full speed. Slow down. And stop. Big thumbs up. Great, that was much easier than I thought. So now I just need to find a frame for the stepper motor itself. And of course I already have an idea for this, and it's this metal plate right here. This is just a perforated metal plate, standard issue 4mm holes or something. So I expanded one of these holes here, and so by lucky coincidence, when I put the stepper motor shaft through here, 2 of the screw holes on the stepper motor line up perfectly with 2 of the holes on this plate here. So that's going to work out very well and be really easy to set up. So I need to introduce 2 bends into this plate here so that I can fix it down at the end and then have the motor be out further this way. Be right back. That went pretty well. The important thing here is that this surface up here and this surface here are more or less parallel, and indeed they are. So let me show you where I'm going to hang this. Excellent. So the frame for the motor goes on here. Motor sticks out through here, and then here's that other frame which will go on here somewhere. We're gonna just fix this on here first and see how it all works out. Very sturdy. So now I can finally reassemble the wheel. Cool, that's the whole frame assembly. Now for the motor mount. The motor is fixed onto the motor mount with some short M3 screws. And there you go, that's all attached. And then I just need some wood screws through here so that I can attach it to this surface. Perfect. So yeah, I've managed to lift the motor too far from the surface now, and it's not going to line up with the wheel. Oh, that could work. Okay. Sure, that's gonna work. Now I just need to attach the little pulley. The little pulley here has a captive nut inside, through which you tighten an M3 screw, which then jams it in against the shaft on the stepper motor. There. Now I just need to connect the motor back up to the power supply. So once I'm done with testing and everything's up and running, I will find a better place for this power supply. But for now I'm just going to stick it right here and see if everything still works. It does not. Oh, I just unplugged it. Okay, so now it's running just fine. So here the stepper motor is running just fine. Now I just need the drive belt, which in my case is going to be a rubber band. And there you go, running very slowly. So hopefully this will fix the problem I was having with the uneven layer of epoxy resin on top of the keys. Let's make some keys and find out. And by that of course I mean that I'm going to go and make some keys, because I already have a whole separate video about that process and the design that I'm currently working with. So about the whole rotating frame idea, is it a good one, is it a bad one, is it a terrible one? I don't know. I'm going to find out over the next couple of days, and I'll be sure to update you on that. I've already changed a couple of things about the design through the magic of video editing, and so here is half of the new frame itself. It's a bit larger and it has some flexible pegs here to better grab onto the keys. And I already also changed the design of the driven wheel slightly. So the next time you see those will hopefully be when I'm ready to proudly show you some finished keys. But there's also a lot of other stuff going on in the Continuum lab right now. I have to finish preparing the pieces of bamboo for the cuts that I need to make to remove the belly section, and also the process by which I make the holes for the keys. And in parallel with that I need to finish some designs of the belly section and other parts inside a blender, so that I can get those measurements exactly right before I actually make any cuts. So I'll be sure to keep you updated on that process in upcoming videos from the Continuum lab. See you soon.